This is the repository I'm trying to use today. I'm going to present, there's a small project in my company. I worked with in the last quarter. We try to use Istio gateway and try to writing a plugin into the Istio gateway using Rust. This is basically the structure. I'm going to present a live demo. The people always said presenting a live demo is a nightmare. I'm going to try. So basically, this is a filter. We try to validate a header in the HTTP request. I can give you a little bit of background about our project. We are working on a gaming platform, so there's a multiple game developers, so they are working on our platform. So once they created the game, we will give this developer a private key that they will sign this every of the requests that they're sending to our platform. So its original design is we have a lot of the microservices validating these keys in the header, but we are trying to do that in a single place. That's the motivation. We are writing a header a filter to validate this header. So to get it simplified, I'm writing this is a server. It's written in Golang. It's pretty simple. I can show you in the IDE. That's the better one. And I'm going to present two kinds of the filters today. The first one is the static one. It's only validated if the header exists or not. This is a very simple configuration. And another example is the second one, using a dynamic configuration, how is loaded. This is basically the same structure we are using in production environment, but only simplified with a static, with only configuring a few, way less headers, validated headers. Also, there's some scripts that I'm using. I will show that in IDE. Any questions so far? Since not, good.
So is the filter, hi Bochin, is the filter going to live in an Envoy proxy?
Envoy proxy, yes.
Is it going to load? Okay.
Yes, the filter will be loaded into the Envoy proxy and will be running inside that process.
Okay.
Yeah. Yeah. This is the server. It's pretty simple. It's just a recording what's request method, request URL, go loop in the headers and print all the headers and print the actual message, actual blank lines, and always return 200. And this is the deployment of the, can I make it larger? No. Okay. The deployment of this server is built into an image and is listening to a node port. This is a node port I'm going to present later. And this is the Envoy, it's not Envoy, Istio gateway configurations. And the host, the most important part is the host. So it doesn't care about what is the host coming in, and it will forwarding any of the requests into this host. This is the service name matching this one. The very simple Kubernetes service. Let me present here is, let me show you. Can you see this screen, right? I'm not sure if I can scroll to the second desktop.
I can see the screen, yeah.
Okay, good. This is a very simple like sample Kubernetes cluster, 4 nodes, and I'm currently in default namespace, and there is already have a Istio installed. If you're looking at that, I can get. Yeah, this is the Istio namespace. I'm on another machine. That is my development Linux box. This is my local. So this box is running on the default namespace. And this one is in the Istio namespace, connecting the same cluster. And the first thing I'm trying to do is, for my local, go to the server, get the server deployed. Then you see this is the server here. Then let me tail the log in this larger one, then curl the 3000 once. You will see if I curl the command, the port of this node port, that's the server directly, you will see the server will print out. This is a GET request. And this is the header. It's very simple. But if we have, this is a simple script to get what is the port of the Istio proxy. So if I curl the endpoint from the Istio one, Istio injected into a few more headers. That is not the super concerns today, but I will see if you use a different port that is actually going through the Istio envoy proxy. This is the place we are going to inject the filter. So let's go to what the filter do. This is the dynamic one. Let's go to the static one first. This is basically everything copied from the envoy proxy sample. This is the HTTP context, and this context called auth handler. And in our auth handler, we're overriding a few methods. The logic is go through all the headers. If this one exists, this token exists, then assign this to the token and put an actual header here saying the header is hello from the actual header here. So rewriting the token from the requests going through this proxy. And if the token does not exist, it will return for3 forbidden. And the proxy will be stopping, and there's no other more requests going to the downstream real HTTP service. This one's purely running in the envoy proxy. To get it running the proxy, this is the YAML file applied to the Kubernetes configurations. It's running in Istio systems. That means this proxy will be applied to all the services running in the whole cluster. If this is the default, this will be only affect the thing running in the pods running in the default namespace. Yeah, this is basically everything that's written in the example of the envoy proxy. A little bit differences you need to be careful about apply to HTTP filters, and also need to be up-to-date names of this. If you Google envoy proxy or envoy filters, this will sometimes give you the outdated examples. This one matches the latest one. This is the second part, is define where is actually you can download the proxy. I will compile this library into a WebAssembly here. And this one is actually the host. I'm running a simple NGX server, so you can download it. And this one is the SHAR fingerprint for this file, so you can download it and replace it when this one gets updated. I have a simple script here in this directory, so I will run this in the demo, but I need to explain what this script's doing. Clean the project, build it into WebAssembly, copy this one into a place that I defined in the host, and copy this one. Basically, it's the same thing defined in the YAML I just showed. Calculate the SHAR, replace the SHAR with the right one. You can try this. It's actually replacing the whole line from the YAML file with the right SHAR generated here. Then the last one will apply this one. Let me show. So go into this host, static one. I will use the install scripts. This is going to be compiled, writing, then I'm trying to hit this again. This one got 403. This means our proxy, our filter is already kicking in and returns rejected this method without the header. Add the header with anything. Returns 200, and you can see this token is injected into the request, so the HTTP service can actually parse in whatever is inside there. So in our use case, we decoded what's in the header and putting extra other headers, so our service can trust the proxy gives us. So it's the most important reason we're using Rust, because of the efficiency and the performance. Yeah, this is the static demo. Let me go back to the screen. Yeah, sharing the screen, I cannot see anything from you. Questions for now? No? Okay. I will move on to the next part, is the dynamic ones. Let me show you what is actually yeah, this is a dynamic one. The dynamic one is a little bit different. This one is not HTTP context anymore. This is a root context, because root contexts have capable of reading our configurations. Our configuration is very simple here. It's a config key is using the library to parsing it from the JSON format. The config key, the configuration is actually valid keys. It's a vector of string, so we will list all the valid keys in this configuration. And the rest part of this is the same, except this root container, the root context will create HTTP context, and the rest of the HTTP context is the same. To demo is a different one. I'm not using the hello from token. This one being replaced with token is something. And the rest of the part is the same like the static one. In the configurations, there's also a few changes. This is the configuration part. Compared with the static one, this is pretty, only this one is the new one. The rest of the configuration is the same. So this is the config type. This one will be parsing into the root context and will be set into the system direct dynamically. Now, this only the valid key is okay. I'm going to show the live demo here is here. Go to dynamic, install it. Okay, nice. Yeah, this one is installed. And if I'm trying this, it's forbidden now because of this random ASDF is not the valid key. But if I'm using, okay, it's parsing it's passing the filter. If it's 200, hit the real service, and the real service now is updated to token is okay. That proves this is the newer version of the dynamic filter. It's not the older ones. Let me make a few changes here. Oh, before that, let me show you this one. This is still running in the same pod. This one is now it's up and running about 10 minutes. It's not restarted. Now I'm going to do is I'm going to add another valid key. Okay, here's my valid key here is okay. Let me get another key added here. And the Istio proxy, yeah, it's restart twice. Don't know why, probably running off some incident in my host. And I'm going to apply that. Yeah, it's configured. And the curl, the same thing. It's okay. Still there. Using another token. is also passed, returns 200, and token is ASDF. So because I just showed you this is dynamic config, so the Istio proxy is not restarted, and our actual HTTP server is not restarted. So the configuration file is dynamically injected through the Istio configuration framework. It's not actually requiring any of the restart. This is very important for us because we, as a platform, we are accepting a lot of the connections simultaneously. So we don't want like any of the new games they created need to be restarting our infrastructure. Yeah, it's basically what I'm trying to present today. This is a very simple proxy, but in the real world, this is not as simple as this. This is a proxy. This is an endpoint, how to get the list of valid private keys. And also we have a more complex validation rules here, because that is a signed RSA key. Then we have another library to decode that using the developer public key to decrypt the message. So fundamentally it's the same. It's just a different implementation. This one is very simple here, just for that. Yeah, this is all I'm presenting today. The link of this, in case someone joined later, the link of this project is posted here. I also going to upload this into our Meetup repositories. Yeah.
All right.
Thank you.
Awesome. Yeah. Thank you very much for presenting today. Yeah, if I knew more about Kubernetes, then maybe I'd have more questions. But yeah, I've never used Istio or Kubernetes before.
Mm-hmm.
Any questions from anyone else before we move on? All right. So I'm going to move on to the news segment for today. It's going to be pretty short. Let's just get going here anyway. Where is it? Here it is. Hopefully you can see that. So yeah, I only got a couple of stories this time. Haven't really been following the news too much lately. Been pretty busy at work, so yeah, maybe a lot of other people are busy this month as well. But this is the story that I found most interesting. It was Amethyst is officially halting development of the Amethyst game engine. So if you're interested in game development, yeah, it's kind of interesting. I remember using Amethyst for a while, back when it was kind of the only big game engine, like aside from Piston, I guess, but people had pretty much kind of moved on from Piston at that time already. And yeah, it's kind of strange to see that this project's just kind of decided that it's stopping, but at the same time, it's also very understandable because, you know, Bevy is the new hip engine that everyone's using these days with Rust. And I think they've also kind of suggested in here that, you know, people who used to work on Amethyst may want to look into helping out with Bevy, you know, join forces with them rather than create a competing game engine. So yeah, I guess Bevy is kind of the primary big engine in Rust nowadays. So that's that story. And the other story I found was another one of these Linus Torvalds ones. He was talking about Rust in the Linux kernel again. Did my internet die? Okay, no, it's just very slow. Yeah, so he's been talking about getting Rust into the Linux kernel and, you know, talking about how he's not, you know, trying to get Rust in there, but, you know, if people are motivated enough and they, you know, put the effort in to actually push it through, then, you know, this might actually become a reality. So nothing really new here, but it's just more of that kind of news. Not nothing super exciting. But yeah, that's pretty much it for today's news segment. As always, here are the Manning Publications partnership things that to explain, we have a partnership with Manning Publications right now. There's a 35% off discount code here. I'll be posting all this in chat in a second. And this is good for all products on their website. Here's also the link to the store. And they also wanted to promote this free ebook, a Rust sampler. And yeah, in exchange, our meetup is also going to be getting authors of some of the books published by Manning to come and talk at some of our meetups. So that's why we have Carol Nichols coming in and Tim McNamara in January. So yeah, this is pretty exciting stuff. Check it out if you want a discount on books or yeah, anything that they have on their store. And that's pretty much it. So I'm just gonna post that here. And yeah, the floor is now open for free discussion. If anyone has any news articles they want to talk about or anything they'd like to share, or if you just want to chat, then now's the time. Or feedback. You can also give feedback. Nothing? Going once? Going twice? All right. Fair enough. Okay, I'm going to stop the recording now then.